All right, so now we are going to do volume conversion with the mole. So we've already done particle conversions, we've already done mass conversions, we've done mole conversions, and now we're doing volume conversions. So we're going to be able to calculate by the end of this lesson the volume of a gas at STP, and we'll learn what STP is in a minute, given the number of moles, and then we're going to do it backwards. And we should be able to perform two-step volume conversions with this unit that we will learn. So from mole to volume conversions, it's just this number. So just like 1 mole equals so many grams of the substance, 1 mole will equal 22.4 liters of gas. So this is a constant that we will use to convert moles to a volume. So let's say we have so many particles of oxygen gas, and we want to know how many liters. We will have to do a two-step conversion from particles to moles, and then from moles to liters, and we'll have our volume. So STP just means standard temperature and pressure, and standard temperature and pressure is just at 0 degrees Celsius and 1 atmosphere. All right, so let's get started with our first question. How many moles of helium gas will occupy a volume of 149.3 liters at STP? So you'll always see STP. We don't really change from STP in this unit. So it'll always be at 0 degrees and 0 degrees Celsius and 1 atmosphere. So that's good for now. So we always start, again, with our known and our unknown. Okay, every single one of these, you always first start with your known and unknown. Our known is what they give us in the question, 149.3 liters of helium gas. Unknown is what they're asking us for. So how many moles of helium gas? That's it. So now we're just going to write, we always start with our known. So our known is 149.3 liters of helium. That's what we know. Okay. So remember what's here must go here. So liters of helium. And then up here will be, since we're going straight, we have a conversion from moles to liters, we're just going to go straight to our unknown. This doesn't have to be a two-step problem because we have the conversion factor from moles to liters. And it's actually quite simple. So just like in the slide before, 1 mole, for every 1 mole, it's 22.4 liters. Okay, so this is our conversion factor. 1 mole, 22.4 liters. Now, we just take our calculator, okay, and we do 149. First, we turn our calculator on. Then we do 149.3 divided by 22.4, and that's our answer. So, keep in mind that the significant figures will come from here, and these units will cancel out and we'll be left with these units. So we have 4 significant figures, so it'll be 6.665. And the unit is moles of helium. Okay. So there's the PowerPoint working it out. All right, so what we've already learned, here's all our 3 conversion factors that we've learned. We've already learned that for every 1 mole, it's 6.02 times 10 to the 23rd atoms, molecules, or formula units, or particles. We've also learned that 1 mole is equal to the atomic mass, but in grams. That was the second day. And then the third day we did 2-step conversions. Almost forgot what we did yesterday. And then today we are doing from moles to liters. So for every 1 mole is 22.4 liters. And all of these are constants other than the atomic mass, but it still is a constant because the 1 mole of oxygen will always have the same mass. Okay, so this is just a good, like a little, not a cheat sheet kind of for you. So you'll use this to solve your mole problems. So basically if you're going from mass, where's my mouse? Okay, so from mass to moles, you'll know that you'll do 1 mole over the mass. Okay, so we'll move on. This you can refer to like forever. You can just, I don't know, print it out, or maybe, I think it's on your notes, just fill that out, and then you'll have it. But let's do another practice problem. Okay, so we'll do another practice problem. What volume would 4.32 times 10 to the 23rd atoms of krypton gas occupy at standard temperature and pressure? So again, we're writing our unknown and our known. Okay, so the known is what they give us on the question, so 4.32 times 10 to the 23rd atoms of krypton gas. And then our unknown is what volume. So what volume of krypton, okay? So volume is in liters. Okay, so we always start with our known, 4.32 times 10 to the 23rd atoms of Kr. And then here will be, since we have atoms of Kr here, we'll have atoms of Kr here. And then we need to convert to moles, okay? So first, the mole is like our main conversion unit. So from here, we need to go to moles. And then our next step will be moles. If it's moles up here, we'll have to have moles down here, moles of Kr. And our unknown, we're trying to get to liters, okay? So we will need to do liters of Kr. Okay, so we just need to fill in the numbers. So here, our conversion, remember, for every 1 mole, it equals 6.02 times 10 to the 23rd of anything, particles. And then also remember the conversion factor, 1 mole equals 22.4 liters. Okay, we'll say particles. Okay, so these are the 2 conversion factors we'll need. We usually just convert to moles so that we can convert to whatever it's asking for. Because the reason this is a 2-step problem is because we don't have a conversion factor that says for this many atoms it's this many liters, okay? We do know how many atoms in a mole, and we know how many liters in a mole. So that's why we had to do 2 steps. We don't have a conversion from atoms to liters. We had to convert to moles first. And that's the whole point of a mole. All right, so for every 1 mole, we have 6.02 times 10 to the 23rd atoms. And for every 1 mole, we have 22.4 liters, always, okay? So now all we're doing is we're taking our equation and we're going to plug it into our calculator. I don't know if you can see. We're going to go up here. All right. So again, I like to just put these in parentheses and then divide and then multiply. So we have 4.32 times 10 to the 23rd, close parentheses. And we are not multiplying, we are dividing because the number is other than 1 is on the bottom. And we're going to divide by Avogadro's number, 23rd. Now we are going to multiply because the number other than 1 is on the top. And I don't have to put that in parentheses. 22.4 equals. So again, for significant figure purposes, we're only looking at these 3 numbers. So it's going to be 16.01. I'm sorry, 16.1. 16.1, and these units canceled, and we're left with liters of krypton. So 16.1 liters of krypton.